So we're trying to find the arc length of the curve y equals natural log of cosine of x from x equals 0 to x equals pi over 4. So this is our setup here. And the first thing we do is we figure out which formula to use. Because we're given a function in terms of y equals f of x, this is the formula we're going to use. So our f of x must be equal to the natural log of cosine of x. Okay, and we can also see that we're given our bounds. X needs to be in between 0 and pi over 4. So that tells us that a is equal to 0 and b is equal to pi over 4. Now looking ahead with the formula here, with the formula for L, which is the arc length, we're going to need the derivative of f of x, right? So let's go ahead and compute f prime of x while we're here. So actually what I can do is f prime of x. I'm going to write that a little smaller. So f prime of x is going to be equal to, I'm going to use the chain rule. So I have 1 over cosine of x times the derivative of the inside, which is the derivative of cosine of x, which would be negative sine x. And this is another way of writing negative tan x. So let's go ahead and we can write go ahead and fill out our formula here. So L, let's see here. So L is going to equal the integral. Remember, a is 0, b is pi over 4. So we'll have the integral from 0 to pi over 4. And 1 plus negative tan x squared. And then we need the square root of all of that dx. Okay. And that is going to equal the integral from 0 to pi over 4. 1 plus tan squared x square root dx. Now here's where we're going to actually use a Pythagorean identity, which says that tangent squared x plus 1 equals secant squared x. So this is a Pythagorean identity. And we can rewrite our integral as the integral of the square root of secant squared x dx. But the square root of secant squared is just going to be secant x dx. And we remember that the integral, so this is something we have to remember. You could, figure it out, but we went over it in class several times. It's in the lectures. It should be on your cheat sheet. So by now, you should know that this is the natural log of, what is it? It's the natural log of secant plus tan. So the natural log of secant x plus tangent of x plus a constant, okay? So we're going to get the natural log of secant x plus tangent of x. And this is evaluated x equals 0, x equals 4. It says x equals 0, x equals 4. Pi over 4, sorry. Okay, so this is going to equal the natural log of secant of pi over 4 plus tangent of pi over 4 minus the natural log of secant of 0 plus tangent of 0. Okay, and so now I'm just going to kind of figure everything out. Secant of pi over 4, that's the same thing as 1 over cosine of pi over 4. And cosine of pi over 4 is root 2 over 2. So this will be 2 over root 2. Okay. Now what about the tangent of pi over 4? Tangent of pi over 4, that's just going to be 1. Secant of 0 is 1 over cosine of 0. Cosine of 0 is 1, so that's going to equal 1. And then tangent of 0 is just 0. Okay, so now we're ready to put it all together and say that this long thing is equal to, let's see here, so L equals natural log, let's see if you can see here, so it'll be natural log of this plus this, right, minus the natural log of 1 plus 0. Okay, so we'll have natural log of 2 over root 2 plus, what do we say, plus 1 minus the natural log of 1 plus 0. But that's just the natural log of 2 over root 2 plus 1 minus the natural log of 1. The natural log of 1 is equal to 0, so we just get natural log of 2 over root 2 plus 1. We don't need the absolute values anymore because what's inside them is a positive number. Okay, and that is our arc length.